Good morning, students. Good morning. Am I audible to you, ma?
Yes, ma'am.
Yes, thank you, ma. So, good morning once again. So, we will start the class. In the previous class, we have discussed about the conversion of regular expression to NFA. Okay, and for that, we have seen the first two principles or first two methods for R1 plus R2 and for R1 into R2. We have seen. I hope you remember. Please go through your notes once what you have written. So there are primitive regular expressions, as we know. Any symbol that belongs to the input alphabet sigma, and then lambda, and then phi. All these are all primitive regular expressions. Okay, and from this we'll be able to construct other regular expressions using the operators plus, dot, and star. Okay, so that's why we will be having R1 plus R2, R1 into R2, and R1 star. Okay, so we have regular expressions like this. And as I told you, this all these NFA and DFA and the regular expression, all these are representing the regular language. Okay, so all these are all little equivalent to each other, and so we have conversion methods from one method to another thing. Okay, so we have conversion from regular expression to NFA, and we can find the equivalent DFA for the given NFA. Okay, but from DFA you cannot find a NFA. Okay, so from DFA, NFA to DFA, and from finite automata. Okay, either NFA or DFA to regular expression. Okay, so these are the conversions we need to study. So first thing what we are studying now is the regular expression to NFA. So for that, I told you how to convert a regular expression to NFA for the first primitive regular expressions. If it is simply a symbol, then we can draw an NFA like this. Okay. If it is lambda, similarly like this. And if it is phi, there is no connection between the states because that is an empty language and there is no string at all, not even an empty string. And also we have seen R1 plus R2. Okay, so we have seen for R1 plus R2. That is, so we can draw a machine for R1, okay, but that will not be the final state, and we will draw it for Is it visible, ma? Is it visible what I'm drawing? Yes or no? Okay, I guess it is visible. There are 61 in the meet and there is no one to say at least a yes or no. Huh? Are you all there in the class? Is it visible or not, ma?
Yes, ma'am, it's visible.
For getting this yes from you, I have to take 2 minutes now. You see, huh? Why can't you respond? So if it is R1 plus R2, then we can draw the separate machine for R1. Okay, the NFA for R1 and then for R2, and we can have a common initial and final state, and we can connect it with the lambda edges. Okay, so this is what we have discussed that day. And similarly for R1 into R2. Okay, for R1 into R2, the same way it has to be concatenated. Okay, we have a machine for R1. Okay, and it is not the actual final state. And we have another for R2. Okay, so we can concatenate these two using a lambda transition, and then finally we can have a final state and then common initial state. Okay, so all these are connected with the lambda edges. Okay, so up to this we have discussed on that day. So now we will continue with the next one, that is R1 star. Okay, the next one is R1 star. So what is the meaning of star? It means that it occurs 0 or more number of times. Okay, the regular expression may repeat 0 or more number of times. So what is the meaning of 0 times it is repeating? So that means it does not happen at all. Okay, so so we'll first draw the regular expression for R1. Okay, you have a you have a machine. We have an NFA for R1. Now this now how we have to draw the R1 star is that, so if it is 0, if it is occurring 0 number of times, that means it will not occur even once. Okay, it means it does not happen at all. Okay, only 0 number of times. So that means you can directly move on to the next state. Okay, so using a lambda transition, without even reading this regular expression, you can directly move on to using a lambda transition, you can go to the next part. Okay, whereas if it is one or more number of times, then it will again loop around the same regular expression, because here is where your R1 regular expression is there. Okay, so this will keep on looping around by reading the lambda, by reading the lambda any number of times. So first time your regular expression you are reading one time, and if you want to read for the second time, then using a lambda transition, again you go back to this initial state and again read that R1. Okay, so this will go on a loop. Okay, so if it is reading 0 number of times, okay, 0 means you can directly go on to the next final state or the part that is continuing with that. Is that clear? Okay, so this is the final state. So if it is 0 number of times it is occurring, then you can directly go to the final state. Otherwise, so it will read for the first time and then it keeps on looping around to read any number of times. Okay, so now these are the general patterns on how we have to draw the regular expression. So now I will give you an example and I will show you how to draw it. Okay. I hope you would have copied it, so I'm rubbing this from the beginning. So please be attentive in the class. At 10:30, I'll be giving you an assignment. Already I have given one assignment in the Google Classroom yesterday for extended transition function, and that no one has submitted it. So today, the last 15 minutes, you'll be doing that. Yeah, I'll give you the GCR code. So you will be doing your problem and you have to submit it. You can just take a picture of your solution and you can submit it in the given link. along with that, I'll give one or two problems from this also. So today's attendance will be taken from that only. Okay, so whoever has completed and submitted before the class, for them only the attendance will be given. So please be attentive in the class and. Your Google Classroom code is given in the chat box. Okay, so right now you need not log into that. You just listen the class now. At 10:30, I'll give you time for that. So I think for the problems given there now, it requires only some 15 minutes. You can complete it and submit it in the Google Classroom. So now let us take a regular expression. R is equal to A plus BB the whole star into BA star plus lambda. Okay, so this is the given regular expression. So now we want to convert this regular expression into NFA. Okay, convert given regular expression R is equal to A plus BB the whole star into BA star plus lambda into NFA. So what we can do is, so you can just make you can make it simple so that you will be able to draw the NFA part by part and you will be able to complete it. Okay. So how we can do that? When you look at it as a whole, you can see that it is we have a whole thing like a R1 star. Okay, so now this you can take as a regular expression separately, R1 the whole star. Okay, just now we have seen how to draw a NFA for R1 star, and here you have we can call it like R1 plus R2. Okay, or you can give some other name also, R2 plus R3. Okay, so we have a plus operator here, right? So R2 plus R3, you can have it. And what is in between here? Concatenation, a dot. Okay, so you can draw it bit by bit and you can combine it. And if you want to make it reduce, so you can see this R2 can be again a dot operator. Okay, B into A star. Okay, B into A star. So this is again a concatenation, and this itself is a star operator. So you can do it so as when you keep on practicing, it becomes easier and you will be able to do it together. Okay, so now let us do it one by one. So first, how will you draw for A plus BB? Okay, then we will do the star. So first, what is A plus BB? So we have seen that when you are having union operator, so you need to draw it separately and you have to combine it using the common initial and final state. Okay, so now what is here, what this machine will have and what this will have? This will have A and this will have BB, right? A plus BB. So that is what this machine you want to construct. So for constructing A, how will you draw? You will be having a separate NFA, you can draw it. Okay, and for BB, how will you draw? So BB, it is again actually a concatenation, B into B. Okay, so that means you will have B and then followed by again another B. Okay, so so now we want to join it together using a common initial and final state. Okay, so this is your A or BB. Okay, but what is asked? A or BB the whole star. Okay, A or BB the whole star. So how can you do that for drawing a R1 R star? So again you need to go for another new initial and final state. So now actually this is not the actual final state. So we are going for another final state. But this is also not the actual final state. Okay. So how will you draw the star? So if it is 0 or more number of times occurring, 0 times occurring, then directly it will reach the final state using a lambda transition. Okay. Otherwise, A or BB may happen 1 time or 2 times or 3 times. So it goes on a loop using this lambda. Okay. So 1 time it occurs, reaches this. Again, if it occurs for the second time, it goes back using a lambda transition to this state, and again any of this may happen, and so it keeps on repeating. Okay, a loop. Okay, so this is what now we have drawn it for the first part, A or BB the whole star. If you don't understand anywhere, kindly unmute your mic and stop me and ask me. Okay. The next one is BA star plus lambda. So, and if it is not visible also, please tell me. BA star plus lambda. So again, if you see here, this is an OR operator. Okay, so BA star is one part and lambda is another part. Okay, so how we can draw? First, BA star again. This is a concatenation, and it is not needed that every time you need to, for star operator, every time you need to go for such all the things you need to do it. Okay, sometimes for such thing, for a single symbol you can go on a self loop. Okay, self loop also means the same thing. Okay, self loop also means that it is going to happen 0 or more number of times. So to reduce the number of states, you can go for some such self loops in the case of star operator. Okay, so let me do it like that. So we will be having B, okay, and then followed by A star, okay, B, A star, and then we have another thing here, we have OR lambda. Okay, so that means this will also go to a final stage, and again using a lambda edge also you can go to a final state. Okay, so either BA star, by reading BA star you can move to the final state, or directly by reading a lambda you can go to the final state. Okay, so that is BA star or lambda. Okay, now this is the second part of the regular expression that is given. So now how can we combine both of these things? So we have it, we have a dot operator, concatenation operator in between both of these things. Okay, so now that means you will be connecting this with this state. Okay, connecting this with the second regular expression, and that is using a lambda operator. Okay, using a lambda operator, now we are connecting this with this. So that means this is not the actual final state here. So we will be having a common initial state again. Okay, we have a common initial state here, and also will be so now this is also not the actual final state. So we'll be having a common final state for both of them after concatenation. Okay. So are you able to follow this? Those who have those who can understand can kindly put a yes in the chat box, ma'am. Yes, Asborn, Christina, thank you. Yeah, Johnson, Nancy, Roshan, good. But there are several in the classroom and getting response only from 10 or 15 people. Okay, so this is how we will be converting the given regular expression into the NFA. Okay, so now I'll give you some more problems so that you can work it on. Um, so kindly take down this problem. So now during the remaining time, you can access your Google Classroom, and the first assignment that I have given, that also almost half of the class has not submitted yet, the derivations from a grammar. So all these class assignments will be considered for your qualitative assessment mark. Okay, so kindly submit all the assignments. The first assignment you have, but today what you are going to do is you can submit this extended transition function, what I have taught you in the previous class. And also now I will give you one more problem from this regular expression to NFA. This also you have to complete and submit it along with that in that same link. Okay, so take down this problem. Convert the given regular expression to NFA. So the language given is L of AB star AA plus BB A star AB. Okay, so L of AB star AA plus BB A star AB. Okay, so this is the regular expression given. So you have to convert this into an NFA. So I will not take the attendance at the end of the class. I'll just check the Google Classroom for your submission. Okay, I have created a link for extended transition function under class assignments. So there I have given you 2 problems that also you complete, as well as this problem also quickly complete before the end of this class and submit it. So that will be considered as your attendance for this class. Okay, so you can start do it, ma'am. Those who have joined recently to the class, if you're not getting your meet link in the online.Karnia, kindly post your numbers in the chat box so that I can add it in the online.Karnia.edu. If you are joining newly to the class, because I could see some of you have yes, Mark Daniel.